Welcome back, learners. You know, in the previous video, what we have done in the ETABS software, you can see that we have assigned all our beams. Okay, that is the beams of the plinth beam, then roof beam. In the roof beam indicates the first floor beam, and the second, that is ground floor beam, and the first floor beam. Now, yesterday itself, I told you, that is in the previous lecture itself, I told you that we have made the three categories of the beams. Okay, so beam number one of the smaller dimension, beam number two of the larger dimension, beam number two of the medium dimension, beam number three of the larger dimension. But here we have provided all the beams, that is plinth as well as roof beam, all are of the same dimension. So if we do like that, definitely nothing will happen, but your section becomes uneconomical section. Why it becomes uneconomical section? You may have the question. Because the load coming on all the beams will not be same. So therefore, definitely what will happen, some beams which is not having much load, if you are putting unnecessary the larger dimension beams, then definitely it becomes uneconomical. In the same manner, on the beams which receives the high loads also, if you are putting a very small beam dimension, then definitely the beam is going to fail. So therefore, by keeping both the things in mind, we have to understand that where a particular beam has to be decided. Now, before we go on to the roof beams, so first we will discuss about the plinth beam. Now, I'll just remove the extrudeds. Okay. So once the extruded is done, you can see this is how your structures looks like. Now, I clearly told you that if I make it in the form of the elevation, okay, like this, let me put in the form of elevation, right? Now, when I put it in the form of elevation, you can see that this is our ground level. I told you the software will definitely, okay, the software will definitely will not understand the ground level or above the ground level. For the software, everything starts from the ground itself. For the software, everything starts from the ground itself. It means for the software, this is the starting point, that is ground. Okay, this is the starting point, that is ground. Then for it is first floor, this is second floor, this is third floor. Okay, but I clearly told you that for us, this is the ground level. Okay, this is my ground level. Okay, so this is my ground level. So here there will be plinth beam. Okay, here there will be plinth beam. So whatever this column part is there, this column part is present below the ground level. This column part is present below the ground level. So this is my ground level. This is my one floor. This is my another floor. Okay, this is my one floor. This is my another floor, and this is my ground level. So therefore, whatever the beam we have provided here, all those beams are plinth beams. Now, one thing I wanted to make you very clear that the load on the plinth beams are very less. Why? This plinth beam will be resting on the soil. Okay, the major two reasons I told you that why we provide the plinth beam. The first reason that why we provide the plinth beam is in order to make the column stiff. For example, if you see the column of this is only from here to here, that is 10 feet. The column of this floor is only from here to here, that is 10 feet. But if I am not putting this plinth beam, then the column will be considered from here to here. So therefore, the length of the column increases. So there is a chances of the failure of the column by buckling. So in order to make the column more and more stiff, we provide the plinth beam. Okay. And the second reason is we have to construct the wall here. To construct the wall, either we have to put the foundation here or we have to put the plinth beam. For these two reasons, we are putting the plinth beam. Since the plinth beam is resting on the soil, the load received on the plinth beam are much lower compared to this beam and this beam. Okay, the load received on roof beams are higher compared to the load received on the plinth beam. Okay, the load received on the plinth beam are much more lower than the load received on the roof beam. So therefore, what I can do, I can reduce the dimensions of the plinth beam. The plinth beam will receive only the self weight of the wall. For example, if this is the beam, if I construct a wall here, whatever this wall load is there, that wall load will be placed on the plinth beam. That wall load will be placed on the plinth beam. Okay, that wall load will be placed on the plinth beam. So therefore, the load received on the plinth beam will be much more lower compared to the roof beam. Therefore, out of the three beams that what we have defined, okay, out of the three beams what we have defined, 9 inches into 1 feet, 9 inches into 1 feet, 6 inches, 9 inches into 1 feet, 8 inches. Let us make the plinth beam as 9 inches into 1 feet. Okay, let us make the plinth beam as 9 inches into 1 feet. Now, in this video, I will explain you the shortcut method that how you can directly make all the beams of the plinth beam, of all the beams as a beam number 1. Right. Now, in order to do that, again go to the plan. I'll give apply. Now I am in the top floor, that is roof. I'll come down. Okay. So now this is my plinth beam. Okay, you can see this is my roof beam. This is my plinth beam. Okay, I'll make everything to look in the objects because the color will be highly appreciable. Right? Yes. So now this is my plinth beam. Now you can see that the plinth beam, whatever is present here, it is of beam number 3. That is my third beam. Okay. Now I wanted to convert this to beam number 1. That means I have to change this beam to beam number 1. Now, one way is you can delete everything and you can make it. But if you do that, it consumes a lot of time. Okay. And you have to again go back to your plan in the AutoCAD. After going back to the plan in the AutoCAD, again you have to check that wherever beams is present and everywhere you are supposed to do that. So in order to avoid that, you have an option, what you call it as assign here. Right. So therefore, what I'll do is I just need to change all these beams which is in the beam number 3 to beam number 1. Now, how you check that whether it is in beam number 3? Just click on any beam. Just click on any beam and just right click on this. Right. When I right click on this, just see here, there will be a yellow light blinking indicating that this beam you have selected, and it will show you all the properties. You can see here for this beam, whatever I selected, it is a beam 3 of 9 inches into 1 feet 8 inches. Okay, everything can be seen here. Geometry also it can be seen. What is the length? You can see it is the length. Then once the load is assigned, even it will show you the loads also. Once the design is done, even it will show you the reinforcement details also. But as of now, nothing we have done. Therefore, you can see only assignment. It is a beam 3. Right? You can, like that, you can check any beam. Right? Select that. Right click. It will show it is also beam 3. So it means all my beams here are beam 3. Now, how to convert it into the beam 1? Simple. First thing you check whether it is 1 story or all story. I need the beam to be changed only for this. Therefore, I am keeping 1 story. Now, after this, what you do, you select all these beams. Okay, if you do like this, what will happen? All the columns will be selected. I need only the beams to be selected. Therefore, I'll select all these beams. Okay, I'll select all these beams like this. Right? I'm selecting each and every beam. Right? Yes. So once my all beams are selected like this, once my all beams are selected like this, okay, what I have to do, go to assign. Okay, go to an option which is there next to select, go to assign. In the assign, now I have to choose frame. Frame indicates beam and column. So therefore I have to choose frame. Now in the frame, which one I have to choose? I have to choose section property because now I wanted to change the section of the plinth beam. That is, the beam 3 section is present for the plinth beam. I have to bring it to the beam 1. So therefore what I have to do, after selecting all the plinth beams and keeping it in the one story, go to assign. After going to assign, go to frame, and in the frame go to section property. Go to section property. So click on section property. Now the existing beam is beam 3. Now what I have to do, I have to make everything to beam 1. Therefore click on beam 1. Click on beam 1. After clicking on beam 1, give apply and give OK. So once it is done, automatically for every beam there will be a notification will come on that. See, it is a beam 1, beam 1, beam 1, beam 1. Now you can see that all my beams are beam number 1. Right? If you want, right click. So it will show beam 1 of 9 inches into 1 feet. Right? If you go to beam, if you go to the next floor, you can see it is beam 3. That means all my beams are beam 3 only. Okay, all my beams are beam 3. Okay, all my beams are beam 3. Now again I will go to the next one. All my beams are again beam 3. Right, all my beams are again beam 3. Right, so therefore you can see that now only my only my plinth beams has been changed to beam number 1. Only my plinth beam has been changed to beam number 1. So therefore now if I bring it to the 3D and if I give extrude option, okay, if I give extrude option, right, or before that I will change it to section properties. I'll give apply to Windows, apply, okay, and now if I give extrude option, right, right, yeah, just give me a second, I'll give the extrude options. Where it is, yeah, would just give me a minute. Yeah, what happened, just give me a minute. Yeah, 1 second. Yeah, I'll just explain you. So first, let us finish this. So now, therefore, if I choose with respect to your section properties, okay. So what I can do, I can now see that my all beams, okay, my all beams are, yeah. So now I can see that my plinth beams are of different dimension. Okay, I can see that my plinth beam, right? This is base. So now if you go, this is my plinth beam of beam number one, and this is again uh, ground floor roof beam, and this is first floor roof beam. Okay, so therefore now what I have done, I have clearly changed the plinth beams. Once the plinth beam is changed, now again I told you, even in the roof beam also, okay, even in the roof beams also, so we have kept all the dimensions of the beams as beam number 3. Okay, so what we can do here also, we have an option that some beams we can make it as beam number 2, that is medium loading beams, and some beam we can make it as beam number 3. Okay, so now let us see that how we can change that roof beams, right? And one thing I will tell you, students, now I'm just changing the beam dimensions, and once the analysis is done, so we can make sure that if that beam is going to fail, then you have an option to change, right? We are just checking whether our beam dimensions are sufficient or not. Okay, so therefore I'll go to the one story, and here again let me go to my ground floor, right? Yes, so now my all beams are of beam number 3 only, right? Yes, so my all beams are of beam number 3. Now let us go one by one, right? Yes, so now this is beam number 3, now this is also beam number 3, and this is beam number 3, this is beam number 3, this is beam number 3. See, since this is entire thing, it is a cantilever portion, so let us keep all the beams as beam number 3 only. Okay, so because there is no column here, no column here, or no column here, so let us keep all the beams as beam number 3 only. Okay, yes. Now let us go to this beam. You know, this is a very large beam. Okay, this is a very large beam. So this, therefore, we can keep this as beam number 3. And since this is a secondary beam and this is the primary beam, even though the area of the load coming on this beam is less, I cannot make this to beam number 2, because I first in the previous lecture itself I told you that the main beam, which is having the one dimension, the secondary beam will have other dimension. The dimension of the secondary beam should be equal to, or it should be less than that of the main beam. It should not be greater than that of the main beam or the mother beam. Therefore this and this also I cannot change, but I can change this and this and this. Okay, I can change this and this. Okay, what I'll do is, since I'm keeping this as beam number 3, I cannot make this to beam number 2, because I'll tell you the reason, students. Even though the load coming on this is less, in practice, when the laymen are casting this beam, they don't cast this beam and this cantilever beam separately. They'll cast this entire beam together. Okay, they don't cast this beam and this beam separately. They'll cast this entire beam together. So therefore, we cannot make the depth of this beam and we cannot make the depth of this cantilever beam separate, and it is not safe also. Again, the one more point I'll tell you, your depth of the cantilever beam should be either equal to, or it should be less than that of the beam which is present behind it. Okay, so therefore either I can reduce this, but I cannot reduce this. Okay, therefore what I done, all my cantilever portions I kept it beam 3, and then since this is a very large beam, I am not reducing this, I'm keeping as it is. And since this is a mother beam and this is a secondary beam, it cannot be reduced, therefore it is, I'm keeping like this, and even this is continuation, and even this is cantilever, it is continuation. Only I can change these two. So let us do this beam and this beam. I'll just assign them to beam number 2. Okay, so beam 1, all beams are plain beam, and let us make this to beam number 2. Apply. Okay, so therefore you can see beam 3, beam 3, beam 3, beam 3. This is beam 3, this is beam 2, this is beam 2, and this is beam 3. Right, and now again I can make this as beam number 2, and this I can make, I have to make it as beam number 3, sorry, beam number 2, because this is my main beam, this is my secondary beam, so the depth of this beam is much more larger than this, it is not possible. Therefore even these two beams also I'll make them as beam number 2. This one I'll make them as beam number 2. Okay, so I'll make this as beam number 2, and definitely let us keep all these three beams as beam number 3. Okay, because it will take little higher load, and even this beam also it will take higher load, therefore this and this, all these three beams I'm keeping as beam number 3. Now when it comes to this, again I have to change, I have to keep this and this as beam number 3. Okay, this I can make it as beam number 2, this I can make it as beam number 2, this I can make it as beam number 2. Okay, because it is a secondary beam, either it can be beam number 3 or it may be beam number 2. What I'll do, I'll make this and this, all the three beams I'll make it as beam number 2. This one, this one, this one, let us make it as beam number 2. Okay, so this and this I'll keep it as beam number 3. Since this is the longest beam, so we will not change this, we will keep it as beam number 2 only, sorry, beam number 3 only. Even this and this I'll keep it as beam number 3, I'm not going to change. Okay, and even this will be cantilever, I'm going to keep it as beam number 3 only. Okay, and even I'm not going to change this beam as well as this beam, I'll keep it as beam number 3 only. Okay, and actually there has to be one beam here, I forgot to add, I'm adding now, and that beam I'll keep it as beam number 2, and these two also I'll make it as beam number 3. I'll make it as beam number 2, and I'll select from here to here one story, right? So this is my beam number 2, and this which was beam number 3, okay, I'll make it as beam number 2. Okay, I'll make it as beam number 2. Assign frame section property beam number 2. Okay, so therefore this is beam 2, this is beam 2, this is beam 2, whereas these two are beam 3, these two are beam 3. Now again when it come here, what I'll do, I will make this as beam number 2, and I will let us keep this as beam number 3, because you can see here there is a very high cantilever beam of almost 7 feet. Therefore let us keep this as beam number 3. This is beam number 3, this has to be beam number 3. Okay, this has to be beam number 3. Okay, so even let us keep this beam number 3, let us keep this as beam number 3, so this we will keep it as beam number 3 only. Okay, so this what we can do, this I can make this as beam number 2, this I can make the beam number 2, this also beam number 2, all these beams I can make it as beam number 2, since the area is less, right? So let us assign to beam number 2. Okay, yes. So now my beams has been assigned. Okay, my beams has been assigned. Now, once this is done, we have another floor. Okay, yes, we have another floor, that is the top floor. You can see that above this there is no any buildings. Okay, so usually the load which acts on the first floor, that much load will not be there on the roof. Okay, only we can say half of that can be there. You can see here, when I go to the loadings, I'll clearly explain you. If the live load on the ground floor, that is first floor, okay, is 3 kilonewton per meter square, I can have only 1.5 kilonewton per meter square on the roof. Okay, because after that, if there is no any floors, then definitely it is not a floor of living. Okay, it will be just for a recreation purpose. Therefore, usually half of the loads will be considered. Therefore, what I can do, I can select all the beams of the top floor and I can make it to beam 2. If one more floor is there on this, then definitely we cannot do like that. But here, since this itself is the last, so this is the top roof beams, I can select all the beams and I can make it as a beam number 2. Okay, so let us do that. So I'm selecting all the beams. I'm selecting all the beams. Okay, I'm selecting all the beams like this. Selecting all the beams. Right, each and every beam I'm selecting. Yes, so once the beams is selected like this, I'll go to assign and I'll go to section property and I'll make it to beam number 2. Right, so therefore all my beams has been now converted to beam number 2. Right, so like this, now what I have done, I have clearly explained you about how to change the beams. Right, so once this is done, my next method or the next step is, what I'm supposed to do is, I'm supposed to change the orientations of the column. Right, so once the orientations of the columns are finalized, the next step is I have to assign the slab. Okay, or you can assign the slab and even then also you can change the orientation of the column, but usually the column orientation will be finalized and then only the slab will be assigned. Okay, so in the next video, so let us learn how to finalize the column orientations. Then let us learn how to define the slab and then how to assign the slab. That we will see in the next video. Thank you, learners.